Hello and welcome back to this tutorial series on Introduction to MATLAB. In this tutorial, I'm going to discuss some of the practice problem and we are going to implement all those concepts we have learned till now to solve these problems. Let's get started. So these are some of the practice problems that I'm going to discuss in this tutorial, and after that I'm going to give you one homework about 3D plot of sphere that you have to do at your own, which I'm going to discuss in the next tutorial. So let's start our first problem. The first problem is solve the following system of linear equations. If you remember, I discussed how to solve system of linear equation in the MATLAB, so that we are going to do in this practice problem. So these are the three equations. The first one is x plus 2y plus 3z is equal to 14. Second one is the 3x plus 2y plus z is equal to 10, and 3x plus y plus 2z is equal to 11. So these three equations are the linear equations that we are going to solve in the MATLAB. So you know, if you remember that we can write these equations in this format: a capital X is equal to d, where a is the coefficient matrix. So these coefficients from the first equation 1, 2 and 3, then from second equation 3, 2 and 1, similarly from the third equation we are going to write in this a matrix. So I have written this a matrix as which is the coefficient of these equations. Next, this D matrix, which is in the right hand side, is going to be these values 14, 10 and 11, and we are going to write it in the column vector. And then we have to find out this capital X vector, which contains the x, y and z, these variables. So what we are going to do is we are going to move to the MATLAB and we will start writing our equation here. So first I'm going to define a matrix A which contains the coefficients of these equations, which we call as a coefficient matrix. So first I'm going to create a row which contains the coefficient from the first equation. So the row is going to be containing elements these 1, 2 and 3. So this is the coefficient from the first equation. Then we are going to move to the second row. For that we are going to use this semicolon here within the brackets, and now we will supply the coefficient of the second equation. So 3, 2 and 1. Similarly, I'm going to supply the third equation coefficient, which is 3, 1 and 2. If you remember from the last tutorials, we separate these elements by comma or space to create different columns. Now to express the output, I'm going to use semicolon outside of these square brackets. So that means it's not going to display the result within the command window. Now if I press an enter key, you will see in the workspace a matrix A is created. Now next we have to create the D column vector, which is the right hand side of this equation. So I'm using this square bracket to create a D vector. Now I will supply these elements 14. Then we will move to the next row because we need a column vector. So I will create only one column and multiple rows. So now we will move to the next row, and then I will supply 10 and then use semicolon again, and then I will supply 11. And to suppress the output, I will use semicolon, but to show you that this is column vector, I'm not expressing the output right now. So if I press an enter key, you will see we have a D, which is a column vector which contains the element in the column direction. Now we have to just calculate these values and we will store them into the X vector. So this is going to be an X vector, which is a variable I'm going to create, and I'm storing the value of x, small y and small z in this X vector. Now what we have to do is we have to calculate A inverse, and then we have to multiply with D vector. So to do that, I will use inverse of A. So this will give me the inverse of A, and then we just have to simply multiply it with D vector. Now I will express the output, or if you want to display the result into this, then we will use the disk command, which we are going to learn. So we have calculated this X value, and you can see here that we have a X vector here. Now to display the result into this command window, we have to do is we have to call this disk command and supply the X vector to it, and now press an enter key. So we have 1, 2 and 3. So these 1, 2 and 3 value are the values of small x, small y and small z. That means small x is equals to 1, small y is equal to 2 and small z is equals to 3. So this covers our first problem. Next we will move to the second problem, which says create a script file and save it on a folder of your choice. So we have to move to the tutorial where we discussed about how to create a script file. So to create a script file, we will move to the home tab, and over here you can see in this file option, here it says new script. So we will just have to simply click it, and you will see a editor window will appear with the name of the file as untitled. This file is not saved till now. What we have to do is we have to save this file into some folder. So to save it, either you can press Ctrl plus S on your keyboard, or simply go to this editor tab and click on save here. So as soon as you click, you will see that this menu will appear which says select file for save as, and it will save this file in this MATLAB folder, which is default folder. If you click on this, you will see many other different folders. Right now I'm going to save it in this default folder. Next, what we have to do is we have to name this file as, so I'm naming it as a practice problem, and then the file extension is going to be .m, so I will use this .m after that. Now I just have to simply click on it and my file will be saved. So just this practice problem.m file is now saved, and you can see that the location of the file is also visible here. This is our second problem. Now we will move to the third problem. Now write some command in the recently created script file and run it to issue the command to MATLAB. So now we have to write some commands. So if you remember in the tutorials, we are going to start from the basic functions that we write, like clc to clear the command window and clear command to clear the workspace variables. So this we always write at the start of the file so that no previous variables are available. Now what we do is, let's just simply create a vector, and to create that I'm going to use a colon operator. So let's create a value from 0 to 1 with a space size of 0.1. Now to express the output, if you see here, this orange color triangle is appeared and this bar is here. So if you move here, you will see that this is line 2. So because we are in this line number 2 here, and you can see a little orange color warning is here, and this you can see from here as well. If you click at this location, it will ask you to fix it. So simply click on it, fix, and it will put a semicolon after that. Let's create some other vector as. Now this time I'm going to use a linspace command. If you're familiar with this linspace, which is going to create a vector between two numbers from 0 and let's suppose 1, and then we have to specify how many number we want. So let's suppose 11 I want. So it's going to create from 0 to 1 11 elements. Now we have to express this output, and if it contains no error or warning, it's going to show you this green tick here. So let's simply save this file. You can press Ctrl plus S, and now we have to run it. So simply click on this button which says run. So if you see in the command window here, there is no output because we have expresses all the outputs, and we have not used even displays command as well, so it's not going to display any result here. But you can see in the workspace here we have created two vectors A and B, which is of size 1 cross 11. That means 1 row and 11 columns. Okay, so now we move to the third problem. We have created this. So now write some command in the recently created script file and run it to issue the command. So we have issued the command and we saved and write some command. Next, fourth problem is create a 2D plot of the curve y is equal to x square. So this is our curve y is equal to x square. That means we are going to need a x vector, and then we are going to create a y vector, and then we will use the plot command to plot this 2D plot. So what I'm going to do is I will move to the command window for right now. So let's write x is equals to, start from 0 and use 0.1, whatever number you want, and I'm going up to, let's go up to 2. So I will press the output. Let's press an enter key. Now I will create a y vector which is x square. Remember, x is a vector, so we need each and every element square. So what I'm going to do is I will use x, then I will use plot to do element wise operation, then to raise the power I will use this symbol, and then I will put 2 after that. That means x square I'm calculating. So I will press and enter. A y vector will get created. Now we just have to simply call the command plot x comma y. So x is that means we are plotting x on the horizontal axis and y is going to be on the vertical axis. So let's see, press the enter key. You will see we get a nice curve which says y is equal to x square. So x starts from 0 and goes up to the 2, and y start from 0 because start from 0, so 0 square is going to be 0 and 2 square is going to be 4. Now it has a lot of things missing. It doesn't have x label, neither it has a y label, and also the title of the plot is missing. So the next problem is the same. So now label the graph manually or using commands. So I'm going to show you both the way. Let's call again this plot command by pressing the upward arrow key on the keyboard to access the previous recent commands. So what I'm going to do is go to the insert tab and click on X label. So now I'm going to write X axis. Simply go again and click Y label and write Y, whatever name you want to give, Y axis. Now I'm going to put a title to it. So I will write plot of y is equal to x square. So this is now nicely labeled plot which has x-axis, y-axis, and also title of plot is visible. Now close this window now. Next what we are going to do is we are going to do it by using commands. So let's move to our script files, this practice problem. So now one more thing I'm going to discuss here is, instead of rewriting this all the files, what we can do in the MATLAB is we can work in sections. So how we are going to work in sections? So let's move to the next line and simply press this double percentage symbol. So by using shift plus 5 on the keyboard, you can create this percentage symbol and do it 2 times. After that you will see this blue color line will appear here. That means this is one section and this one is another section, and now we are going to create a command from here. So clear CLC and clear, this is going to be our 2 commands which is used to clear the workspace and the command window. Next what we have to do is I will create x 0.1 up to 2, then use a semicolon to express the output. Then I will use x dot square to make y is equal to x square. After that I will call this command figure to tell the MATLAB that we are going to create a figure. Plot, then I will call plot command, then x comma y, plot x comma y, then I will put x label, and then I will write x axis. Similarly I will use y label, y label, and then I will write y axis. Okay, after that I will put title to it. So the title is going to be plot of y is equal to x square. So now what we have to do is, because we have created a section, so instead of clicking on this run button, if you look at here it says section, and over here you will see a run section. So instead of clicking on run, so if you click on this run button, this whole script file will be run again. But instead of running whole script file, what we want just to run this line of commands. So to do that, what we have to is we have to create section in the single script file and click on this command which says run section. If you click on this run section, you will see that only this file, this portion of command is executed, and if you see here we get only x and y vector, right? So because we have only run this section here, if we run whole the file, then a and b is also going to be created. Now we get this figure 1 with the x-axis and y-axis labeled, and the plot title name of the plot is y is equal to x square, and this is our graph of y is equal to x square in the blue region. We don't want any legend here because we have only the single curve here. So let's close this window here. Next we will move to the another problem, this 6th problem, plot flowing curve or single graph and label them. So what we have to do is we have to create these 3 graphs, y1, y2 and y3, sin x, cos x and sin square x on the single graph, and then we have to use legend to distinguish these different graphs on a single graph. So let's see what we have to do. So next what I'm going to do is I will create another section here. So use this percentage symbol here And now we will as usual write CLC clear. This CLC clear is not needed every time, but I'm using it because I want to clear all the previous section values. So let's create an x vector, because now we have sine and cosine, so I'm going to work in the pi value. So I will create 2 times pi. So from 0 to 2 pi I have created a vector with spacing of 0.1. Now we will create these 3 vectors, which is y1, y2 and y3. So I'm naming this variable as y_1. You can name it directly as y1 or whatever way you want. So I'm creating as y1, then I will call sine of x. Next I will create y_2, and then I will call cos of x. Next what I'm going to do is y3, which is sine square x actually. So first we calculate sine x, and then because we have to square each and every element here, there is no need of bracket here, but I'm just using it for convenience. So this way I will create a square of it. So this is sine x square. Now we have created all these graphs. Now what we have to do is we have to create figure, and then we will start plotting it. Now what we have to do is plot x comma y_1, and now I will distribute these different graphs by coloring them with specific line styles and colors. So what we have to do is let's put a red color and create dash lines. So then I will create plot x comma y_2, and then I will use single quote or double quote. You can use any quote you want, then use black color to it and use dot. And one more thing we have to do is we have to put an hold on command after all these lines of plot, because we want to keep all the plots which has been plotted previously. Now we have to call last one, plot x comma y3, for which I'm not giving any color or name, and then finally I will put hold off. Next we will put labels, x label, and then this is x, and I will put y label as well, and this is going to be y. Then I will plot title, and then we know that this is the plot of sine of x comma cos of x, and then it has sine square x. So I'm just naming it as like this. Last but not least, we have to put listen to it to distinguish these different graphs. So we will use this index bracket to call this listen function, then we will use square brackets, and now we will supply these different curves in the same order we plotted them. So first we have sine x, next one we have cos x, and then finally we have sine square x. Okay, so we will save this file, and then we click on this. So make sure you are in the right section, so simply click on the section, whatever section you want to write. So we are in this section, start from 13th line number and goes up to 29, and we will just simply click on this option which says run section. Click it, and you will see we get this plot here. So we have sine x, cos x and sine square x. So in the red color this is sine x, so it starts from 0 and goes up to 1, then again 0, and then -1, and then goes up to here. In the cos x you will see it starts from like this, and in sine square x, because all the values now is going to be in the positive axis, because we have sine square, so it's going to be in the upper bound. So this is how we can plot multiple plots in the single graph. Now we will move to the next problem, which is the last problem. Now it says create a 3D plot of curve given below and label it. One more thing in this you can do is, before doing the last problem, that if you see, notice here that it start from 0 and goes up to the 2 pi, and this is the extra space available. And if you remember, I discussed that we can put limit to the axis, so we can use x limit. So I'm using this x limit only, and we will go up to 0 to 2 pi. Okay, now run this section again, and you will see now that we have this plot up from starting from x start from 0 and goes up to 2 pi, and the y limit is already -1 to 1. Okay, now to discuss this the last problem, third problem, let's create another section here. And to create that, we will use this percentage symbol here, and now we will write clc clear just to start our line of commands. Then what we have to do is we have to create an x vector, and if you see in the problem, x start from -2 and goes up to the 2. So one way to do that is colon operator. We are using colon operator again and again, so let's use some other command. So I'm using linspace. The first element is -2 and last element is 2, and let's just create some elements like 20 up to this. Press the output, use semicolon, then I will need y is equal to x, and then I'm going to take transpose of that, and to do that transpose of x, what we can do is we can use this single quote at the top of x, or we can call the command known as transpose of x. So both do the same thing. Now what we have to do is this is x and this is y. As I did, to create a 3D plot, we must have one row vector and another one should be column vector. So y is equal to x. So instead of writing just x, we have to take transpose of that, so that this is column vector and this is row vector, and then we have to create this z vector. So this z is x. Then we have to do each and every element multiplication, so we do element operations. To do that, we use dot star, and then we have to take e power, that means exponential power, and for that now we have to take x square. So x dot square minus y dot square. Then we close it. Then we call figure to plot, and then we will call surf plot, and then we will supply x, y and z. So put x label as x, y label as y, and z label as z. Finally, I'm going to put the title to this plot. Because we have only single graph, so we are not going to need any lesson to it. I will just write plot of or just simply write a 3D plot. Right, now make sure you are in the right section. Simply click on this run section button, and you will see we get this nicely plot of z is equal to x into exponential power minus x square minus y square, right? So this was actually this problem. So it has x e to the power minus of x square plus y square. So minus is outside of these brackets. I've taken this minus inside the bracket, so this become minus, and this is also become minus. So that's how I've written this command here. Because we have to do each and every element operation, so we did this element wise operation here and as well as here. So this was all the practice problem that I have discussed here. And in the last, I have this homework problem. What you have to do is you have to create a 3D plot of sphere, and then you have to label it properly. That means you have to put label x, y and z label, and then you have to put a title to it as well. And I will discuss this problem in the next tutorial before discussing any other thing. Thanks for watching this tutorial. I hope you like this tutorial. Please like, share and subscribe. I will see you in the next tutorial.